Floquet theory is a branch of the theory of ordinary differential equations relating to the class of solutions to periodic linear differential equations of the form with a piecewise continuous periodic function with period, and defines the state of the stability of solutions. The main theorem of Floquet theory, Floquet's theorem, due to Gaston Floquet, gives a canonical form for each fundamental matrix solution of this common linear system. It gives a coordinate change with that transforms the periodic system to a traditional linear system with constant, real coefficients. In solid-state physics, the analogous result is known as Bloch's theorem. Note that the solutions of the linear differential equation form a vector space. A matrix is called a fundamental matrix solution if all columns are linearly independent solutions. A matrix is called a principal fundamental matrix solution if all columns are linearly independent solutions and there exists such that is the identity. A principal fundamental matrix can be constructed from a fundamental matrix using the solution of the linear differential equation with the initial condition is where is any fundamental matrix solution. Floquet's theorem, let be a linear first-order differential equation, where is a column vector of length and an periodic matrix with period. Let be a fundamental matrix solution of this differential equation. Then, for all here is known as the monodromy matrix. In addition, for each matrix such that there is a periodic matrix function such that also, there is a real matrix and a real periodic matrix function such that in the above, and are matrices. Consequences and applications, this mapping gives rise to a time-dependent change of coordinates, under which our original system becomes a linear system with real constant coefficients. Since is continuous and periodic, it must be bounded. Thus the stability of the zero solution fond is determined by the eigenvalues of. The representation is called a Floquet normal form for the fundamental matrix. The eigenvalues of are called the characteristic multipliers of the system. They are also the eigenvalues of the Poincaré copyright maps. A Floquet exponent is a complex such that is a characteristic multiplier of the system. Notice that Floquet exponents are not unique, since, where is an integer? The real parts of the Floquet exponents are called Lyapunov exponents. The zero solution is asymptotically stable if all Lyapunov exponents are negative, Lyapunov stable if the Lyapunov exponents are non-positive and unstable otherwise. Floquet theory is very important for the study of dynamical systems. Floquet theory shows stability in Hill differential equation approximating the motion of the Moon as a harmonic oscillator in a periodic gravitational field. Bond softening and bond hardening in intense laser fields can be described in terms of solutions obtained from the Floquet theorem. References: see Chicone. Ordinary differential equations with applications. Springer-Verlag, New York, 1999. Ekeland, Ivor. 1. Convexity methods in Hamiltonian mechanics. Ergebnis der Mathematik und ihrer Grenzgebiete, Results in Mathematics and Related Areas 19. Berlin, Springer Verlag ppx plus 247. ISBN 3-540-50613-6. Mr. 1051888. Floquet, Gaston, Sur les copyright quotients differ copyright rentiels linéaires copyright iris coefficients par copyright Riodix, Annals de la Permel Col Normel Super Copyright Ria 12, 47 €88, Krasnozalskaya, M.A., The Operator of Translation Along the Trajectories of Differential Equations, Providence, American Mathematical Society, Translation of Mathematical Monographs, 19, 294 p. W. Magnus, S. Winkler. Hill's Equation, Dover Phoenix Editions, ISBN 0-486-49565-5. N.W. McLaughlin, Theory and Application of Mathieu Functions, New York, Dover, 1964. Teschl, Gerald. Ordinary Differential Equations and Dynamical Systems. Providence, American Mathematical Society. ISBN 978-0-8218-8. 8328-0. MSP Eastham, The Spectral Theory of Periodic Differential Equations, Texts in Mathematics, Scottish Academic Press, Edinburgh, 1973. ISBN 978-0-7011-1936-2. External links: Haswinkel, Michiel, ed., Floquet Theory, Encyclopedia of Mathematics, Springer, ISBN 978-1-55608-010-4.